Hello everyone. In today's lecture, we have to see superposition theorem. Previously, we had started network theorems, and in network theorems, we had seen KVL, KCL, and Thevenin's and Norton's theorem. In Thevenin's and Norton's theorem, we had seen Thevenin's theorem is useful to replace the complicated circuit by an equivalent series circuit which will have a voltage source in series with the resistance RTH. And while in Norton's theorem we had seen the complicated circuit can be replaced by a single parallel circuit which will have the current source in series in parallel with the resistance RTH. In today's lecture, we have to see the superposition theorem. Now, what is this superposition theorem or how we can use this superposition theorem? We will see in detail. For the network with two or more sources that are not in series or parallel, we require the use of mathematical technique such as determinants to find the required voltage or current. Actually, we had seen KVL and KCL. By using KVL, we can find out the voltages, or by using the KCL, we can find out the currents. But if there are two or more voltage sources, then we can't apply only KVL to these circuits. And in such circuits, we have to use some mathematical techniques, and these mathematical techniques are combined in the superposition theorem. In this case, the source is treated independently and the algebraic sum is found to determine a particular unknown quantity of the network. Let us see the statement. It states that the current through or voltage across an element in a linear bilateral network is equal to the algebraic sum of the currents or voltages produced independently by each source. स्टेटमेंट काय सांगते या ठिकाणी? तर आपण द करंट थ्रू म्हणजे एखाद्या ब्रँचमधून फ्लो होणारा करंट किंवा एखाद्या एलिमेंटमधून फ्लो होणारा करंट और द व्होल्टेज अक्रॉस किंवा एखाद्या एलिमेंटच्या अक्रॉसचं व्होल्टेज इन अ लिनियर बायलॅटरल नेटवर्क हे कशाचे इक्वल टू असतं? तर इट इज इक्वल टू द अल्जेब्रिक सम ऑफ द करंट्स और व्होल्टेजेस प्रोड्यूस्ड इंडिपेंडेंटली बाय ईच सोर्स. बायलॅटरल मीन्स टू. तर या ठिकाणी एखाद्या एलिमेंटमधून फ्लो होणारा करंट किंवा त्याच्या अक्रॉसचं व्होल्टेज आपण कसं किंवा कशाच्या इक्वल असतं? तर ईच सोर्सने इंडिपेंडेंटली करंट किंवा व्होल्टेज जे प्रोड्यूस केलं असेल त्याची अल्जेब्रिक सम. नाउ लेट अस सी हाउ वी कॅन फाइंड आउट द करंट. हियर वन एक्झाम्पल इज गिवन. डिटरमाइन करंट्स I1, I2 and I3 using superposition theorem. The circuit is shown. V1, it is 32 volt. Two voltage sources are there. Bilateral network is here. This V2 is 20 volt and resistor R1, R2 and R3 are connected. So we have to find out the current through R1, R2 and R3, means we have to find out I1, I2 and I3. So for this we have to follow some steps. As we see in the statement, this current or voltages are nothing but the algebraic sum of the currents or voltages produced by independently each source. तर आपण या ठिकाणी काय करणार आहोत? पहिल्यांदा दोन्ही सोर्समुळे प्रोड्यूस होणारे करंट्स कॅल्क्युलेट करणार आणि मग ते दोन्हींची अल्जेब्रिक सम घेणार. So in step first, we will determine the current due to V1, that is 32 volt source, and in step 2 we will determine the currents due to V2, means 20 volt source, and finally in step 3 we will combine them, which will be the result of our problem. So step first, to determine current due to 32 volt source, replace the another source, that is 20 volt source, by its internal resistance. So we have to replace this 20 volt source by short circuit, as we discussed previously. If the internal resistance is not mentioned for voltage sources, we have to take it as a ideal, as we know that the ideal voltage source as internal resistance 0, and if there is a current source, then we have to replace it by its internal resistance, means by infinity, that is open circuit. So here voltage source is considered as ideal voltage source, so we will short circuit this branch and we will redraw the circuit like this. To find out the currents through R1, R2 and R3 due to 30 volt source, we will name it as I1 dash, I2 dash and I3 dash. Now this circuit is well known to all of you, as we saw this circuit in the Norton's theorem. We can see R2, R3, R2 parallel resistances, and this is in series with the R1. Now we have to find out the current I1 dash first. How we can find out the current I1 dash? This I1 dash is nothing but the series circuit current, and this I1 dash get divided into I2 dash and I3 dash. So how we will determine this I1 dash? We know the value of voltage source and we can calculate the value of RT, and by using the Ohm's law we can calculate the I1 dash like this. Here to find I1 dash, first we have to find out RT, because for I1 dash is equal to V upon RT. V is known, is it 32 volt, but RT is we have to calculate. Now how we can calculate this RT? From this circuit we can see R2, R3 are parallel and this is in series with the R1. So for this RT we can write here equation RT is equal to R1 plus R2 parallel R3. Here I had put the equation RT is equal to R1 plus R2 parallel R3. If we place the values of R1, R2 and R3, we can see R1 is 20 ohm, R2 is 30 ohm and R3 is 20 ohm. So we can put the values here and we can calculate here. We will get RT is equal to 32 ohm. As we know the value of V is 32 volt here, and we get RT 32 ohm, we will get the I1 dash is equal to 1 ampere. Now step 2. Here we find out I1 dash. Now we have to find out the currents I2 dash and I3 dash. How we will find out these currents? As this I1 dash is get divided into these two parallel resistances, we can use the current division rule among parallel resistances here, and we can find out the current I2 dash and I3 dash. What is the current division rule? We had seen current division rule state that the current through any parallel resistance is equal to opposite branch resistor multiplied by circuit current divided by sum of the two resistors. So for I2 dash we can get equation here R3 into I1 dash divided by R2 plus R3, and for I3 dash we will get the equation R2 opposite branch resistor means R2 into I1 dash divided by R2 plus R3. Likewise shown. This is shown here. I2 dash is equal to, here the circuit is shown As we discussed, by applying the current division rule among two parallel resistances, we can write the equation for I2 dash is equal to opposite branch resistor here R3. Okay, and circuit current I1 dash divided by R2 plus R3. So put the values here. We know the value of R3. We have value of I1 dash which is calculated recently, and place the values here. We will get here I2 dash is equal to 0.4 ampere. Now what is remained? I3 dash. For I3 dash, similarly we can write the equation for I3 dash as here opposite branch resistor is R2 into I1 dash divided by R2 plus R3. If we put values, we will get I3 dash is equal to 0.6 ampere. Okay, so we can get idea here. I1 dash we had calculated was 1 ampere. Okay, and this 1 ampere get divided into here into resistors. I3 dash we get 0.6 and I2 dash we get is 0.4 ampere, means 0.4 plus 0.6 means 1 ampere. Okay, now similarly in step 2 we have to find out the currents due to 20 volt source. Okay, here we get the currents due to 32 volt source, 1 ampere, 0.4 ampere and 0.6 ampere respectively. Now we have to find out the currents due to 20 volt source. How we can find out the current due to 20 volt source? Likewise 32 volt source. Replace the another source by its internal resistance to determine the currents due to 20 volt source. Let current due to the 20 volt source are I1 double dash, I2 double dash and I3 double dash. Okay, so here first we have to find out I2 double dash, as it is the series current and it gets divided into I1 double dash and I3 double dash. Okay, and for that we need to calculate the total resistance, that is RT. So first we will find out RT. RT is equal to, here we can see R2, and this R2 is in series to these two parallel resistors, means R1 parallel R3 plus R2. We will get equation R2 plus R1 parallel R3. ओके, कारण हे R1 आणि R3 दोन कसे आहेत, एकमेकांना पॅरलल आहेत आणि त्यांचा पॅरलल रेजिस्टन्स इक्वलन्स आहे तो ह्याला सिरीजमध्ये आहे, म्हणून आपण इक्वेशन या ठिकाणी राईट केलं आहे RT इज इक्वल टू R2 प्लस R1 पॅरलल R3, that is equal to R2 plus R1 R3 divided by R1 plus R3. If we put the values here, we will get the equation for RT or value of RT as 40 ohm. Now we can calculate I2 dash as by using Ohm's law. I2 dash is nothing but the current flowing through this resistor. This current get divided into these two resistors, means this I2 dash is nothing, I2 double dash is nothing but the circuit current, and for this we can write the formula as I2 double dash is equal to V2 divided by RT. Okay, using Ohm's law. So we can write I2 double dash is equal to V2 upon RT is equal to 20 by 40 ohm. We get I2 double dash 0.5 ampere. Now to find out I1 double dash and I3 double dash, the circuit will be like this, and using the current division rule for two parallel resistances we can calculate the current I1 double dash and I3 double dash as, for I1 double dash we can write the equation as opposite branch resistor R3 into circuit current I2 double dash divided by sum of the two resistor R1 plus R3. Put the values here and you will get the I1 double dash 0.25 ampere. And for I3 double dash, similarly we can write the equation. For I3 double dash, opposite branch resistor is R1, so R1 into I2 double dash, that is circuit current, divided by R1 plus R3, that is sum of the two resistances, parallel resistances. So we will get the value for I3 double dash as 0.25 ampere. Means the currents due to V2, that is 20 volt source, we get where I1 double dash is equal to 0.25, I2 double dash is equal to 0.5 and I3 double dash is equal to 0.25. तर हे दोन्ही सेम का आलं आहे, कारण आपण पाहू शकतो या ठिकाणी रेजिस्टर R3 आणि R1 दोन्ही पण 20 ओहम आहेत. ओके, त्यामुळं ते व्हॅल्यू जी आहे ती सेम आली. आणि आपण इथं पाहिलं की I2 डबल डॅशची व्हॅल्यू आली 0.5 आणि तो 0.5 कसा यामध्ये डिवाइड झाला, 0.25 प्लस 0.25 इज इक्वल टू 0.5. ओके, सो नाव स्टेप 3, इक्वलंट करंट फ्लोइंग थ्रू रेजिस्टर्स R1, R2, R3. Here we can see the डायरेक्शन ऑफ करंट फ्लो. अल्जेब्रिक सम आपल्याला या ठिकाणी घ्यायची आहे. तर आता 32 व्होल्ट सोर्सचा आपण विचार केला तर त्या करंटची डिरेक्शन ही अशी असणार आहे. ओके, आणि 20 व्होल्टचा विचार केला तर ती अशी असणार आहे. पण जेव्हा दोन्ही ॲट अ टाईम ॲक्टिव्ह असणार आहेत तेव्हा काय होणार, जो मोठा असतो त्याचा इफेक्ट जास्ती असणार आहे, म्हणजेच कमीचा. त्यामुळे काय होणार आहे, कमी व्होल्टेजचा करंट त्यातून मायनस होणार आहे. म्हणून आपल्याला इक्वेशन जे आहे आणि R3 मधून फ्लो होणारा करंटची जी डिरेक्शन असणार आहे ती सेम असणार आहे. ओके, त्यामुळे तो ॲड होणार आहे आणि हे दोन काय होणार, एकमेकांमधून मायनस होणार. म्हणजे या ठिकाणी आपल्याला फॉर्म्युला असा मिळेल, I1 इज इक्वल टू I1 डॅश मायनस I1 डबल डॅश. I2 साठी मिळेल I2 डॅश मायनस I2 डबल डॅश आणि I3 साठी आपल्याला मिळेल I3 डॅश प्लस I3 डबल डॅश. आणि मग आपल्याला जे व्हॅल्यूज मिळालेले आहेत पहिल्या सोर्समुळे ते या ठिकाणी पुट करा, सेकंड सोर्समुळेचे जे व्हॅल्यूज आहेत त्या या ठिकाणी आपण पुट केलेत. अँड वी कॅन कॅल्क्युलेट द करंट्स हिअर. दीज आर द करंट्स. जनरली तुम्हाला I1 आणि I2 कॅल्क्युलेट करायला नाही विचारला जात. मोस्ट ऑफ एक्झाम्पल्समध्ये आपल्याला I3 फाइंड आउट करायचा असतो. हिअर वन एक्झाम्पल इज गिवन to you as an exercise. Using superposition theorem, find out the current flowing through resistor R3. तर हा एक्झरसाइज आहे तुमच्यासाठी. डू इट yourself and comment me your answers or message me. Okay, we will stop here. Thank you.